This is section 1.5 for angle pairs. We know what angles are at this point. Now we're going to see how they relate to each other as pairs. Two angles are complementary if and only if the sum of their degree measures is 90. So complementary is a definition. We definitely haven't talked about this yet, and it looks kind of weird. If and only if. That's a phrase that means something. So this definition means the same thing forwards as it does backwards. So you can say two angles are complementary if the sum of their degree measures is 90. You can also say if you have two angles and their sum of their degrees measure 90, then they're complementary. You can say that as well. Same forwards as backwards. Okay, so here's an example. Angle ABC has a measure of 51 degrees. Angle DEF has a measure of 39 degrees. These angles are complementary because if you add their measures together, 51 and 39, that gives you 90. That's what complementary means. It means they add the 90. You're going to see questions like this from time to time as well. What is the complement of a 60-degree angle? Well, complement again refers to if one angle is 60, what's the other one to make the pair of them complementary? You just do 90 minus 60. Okay, and that gives you your 30-degree angle. So we're going to look for angles in this section that are complementary if their measures add to 90. Two angles are supplementary if and only if the sum of their degree measures is 180. So supplementary is a new term. Same concept though, add the angle measures. If you add 34 and 146, you end up with 180. So these are called supplementary angles. Okay, and again, here's how the geometry is written. So you're going to see this a lot. Measure of angle GHI plus measure of angle JKL. That's this guy. Equals 180. So it's important to know how to read that. What is the supplement of a 50-degree angle? Well, supplement refers to 180, so we're going to take 180 minus 50. That's going to give us that same 30. Adjacent angles have this definition. Okay, now in general, adjacent means next to. So in geometry, we're talking about angles that are basically next to each other. So if you look at this diagram, angle 1 and angle 2 are adjacent angles. They're right next to each other. Now, it gets a little more complicated than that, but this is a simple way to look at it. To be adjacent, they have to have a common side. So if you look at angle 1 and angle 2, do you see how this ray is shared on both angles? Don't both angles have ray DB as a side? Yes. Do they both have the same vertex? Well, angle 1 has a vertex of D. Angle 2 has a vertex of D. Yeah, they have the same vertex. Third thing you got to check for, there can't be any common interior points, meaning if there's a point on the interior of angle 1, that point can't also be on the interior of angle 2. Another way to say it is the angles can't overlap. These angles do not overlap. So that's why they're adjacent. Now we're going to look at some examples of angles that may look like they're adjacent, but violate this definition one way or the other. Okay, now if we can compare this adjacent with our complementary and supplementary definitions from the previous slides, You can have complementary angles that are adjacent, and you can have complementary angles that are non-adjacent. That is possible. If you look back at your slides, the ones that we showed you were non-adjacent. They could be adjacent as well. Same thing with your supplementaries. And that's where things get complicated, because we're going to start putting these different definitions together to classify angle pairs. Okay, so are these adjacent angles? Angle 1 and angle 2. They share a vertex, so that's good. But angle 1's made with these two rays, and angle 2 is made with these two rays. So notice how they don't share that common side. Another way to look at it is, if these were classrooms, isn't there a classroom in between those two angles? Okay, so these are not adjacent because they don't share a side. So hopefully you can write that down in your notes. That might take me a little bit longer to write down than I would want. Number 2, look at angle 3 and angle 4. Are they adjacent angles? Well, here's a ray for angle 3. And angle 4 kind of has that same ray as a side, but it's not the exact same ray. Also, notice how they have different vertices. Angle 3 has this point and angle 4 has this point. Also, point R is definitely on the interior of angle 4, and it's also on the interior of angle 3. So this one violates that definition in a bunch of different places. They don't have the same side. They don't have the same vertex. They have common interior points. You could also say that they overlap. Angle 4 lives completely inside of angle 3. Okay, so angle 1 and angle 2, these are not adjacent angles. Number 3, angle 5 and angle 6, are they adjacent? Now, look at the vertices. They're in completely different places. They obviously don't share a side either. These angles don't even touch, so they can't be adjacent. Number 4, this would be tough to see on your notes, but we have a blue angle and a red angle. The blue angle is completely inside of the red angle. They overlap. They do share a vertex. They do share a ray, but they overlap. So are these adjacent angles? No, for all of them. That's what adjacent angles look like right there. These are examples of what adjacent angles are not.